Okay, another example on conditional probability. In this time it says, given the probability of A given B is 0.3, we want to complete a contingency table and evaluate X. Okay, I'm going to do this kind of evaluate X first and then think about the contingency table. The key detail here is we're given that the probability of A given B is equal to 0.3. That's given in the question. And we have a formula for the probability of A given B. So let's put that in. We know that the probability of A given B is always the probability of the intersection of A and B divided by the probability of B. And we know that's equal to 0.3. So, substituting in what we know here, we know in this example that the probability of the intersection is X. That's given. Divided by the probability of B. Now, B involves this whole loop, which has two regions in it. So the probability of the B will be the sum of these two regions. It'll be X plus 0.4 minus X. So the probability of B here is going to be X plus 0.4 subtract X. It's the sum of these two regions, which is going to be 0.4. So X divided by the probability of B is 0.4. That's equal to 0.3. Solving, multiplying on both sides by 0.4, X is going to equal to 0.4 times 0.3, which I think is going to be 0.12. So what are we looking at? When we're looking at this, represents 0.12. This is going to be 0.4 minus 0.12, which will be 0.28. This is going to be 0.7 minus 0.12, which will be 0.58. The sum of all the probabilities has to be 1. So when we add up all these things, we have to get 1. So we're going to just make sure that the outside part is included, the complement of the union. So 0.58 plus 0.12, that's giving me 0.7. Plus 0.28, well that's 0.98. That has to be 0.02, because if I add up all those red numbers, I should get 1. Okay. So complete the contingency table. We've done all the hard work. So we're going to complete the contingency table for this. Complete the contingency table. Just scroll it down a little bit more. So what's the contingency table going to look like? Well, a few vertical lines, a few horizontal lines. My events here are called A and B. So this would be row A complement, total sum, column B complement, total sum. The intersection is 0.12. The complement of the union is 0.02. The sum of all the outcomes should be 1. In A, but not in B, is 0.58. So the total probability of A should be 0.70. In B, but outside A, is 0.28. So adding everything up, that'll be 0.3. That works out nicely. This will be 0.4. This will be 0.6. That works out nicely. That's what my contingency table looks like. We found X. X is equal to 0.12, and that represents the probability of A and B. Okay, and so conditional probability, getting used to these different types of things, getting used to these different kind of types of problems. Okay.